Okay, so today we're talking about, we're going to start proving triangles similar. Don't freak out, these are not two-column proofs. But we do need to calculate ratios and see if they're equivalent to see if we have similar triangles. And you're going to see things that are very similar to when we were discussing congruent triangles. So we have the first three theorems here. We have theorem 7.1, which is angle-angle similarity. So remember how with congruency, we couldn't prove it congruent by angle-angle? We would have to have side-angle side or angle-angle side. We have to have that third component, right? And that's because if angles are congruent, ladies, we'll talk later. Thank you. If we have two angles to prove congruent, think of an equilateral triangle, right? We can have different side lengths, but still keep those same angles. So that would never work for congruency, but it does work for similarity, okay? So we have angle-angle where you have to have two congruent angles in order for these two to be proven similar. We also have side-side-side similarity. As long as the ratios work and they are the same, then these two triangles will also be similar. Then there's side-angle-side similarity, where you will have to have, and it does follow the same criteria as side-angle side with congruency. You're going to have a side, a corresponding angle, and another side. Those two sides need to have the same ratio, okay, while the angles are in fact congruent. So that just briefly explains that. Okay, so the first thing we're going to, the other way you can use this is when we're talking about it, just some abbreviations. You would put AA with a squiggly. This will be side, side, side with a squiggly. Do not just put SSS. You have to put the little squiggly sign to define, are you congruent or are you similar? And then same with this one, side, angle, side. And this will also be with the squiggle. All right, so let's take a look at this first one. It says determine if triangle PQR and triangle STU are or are not similar. And if they are, state how you know. Note that the figures are not necessarily drawn to scale. All right, so in this first part, if we take a look, we see that this is a 45-degree angle. This is also a 45-degree angle. This is a 63-degree angle. This is a 63-degree angle. So therefore, we have two angles. So when we just write down the similarity statement, again, same thing applies when you name triangles. Nothing's changed there. You have to go with vertex to vertex, right? So I'm going to start with P, then go to Q, then go to R. And I'm going to state that similar to the corresponding vertices of this larger triangle. In this case, we're going to start at S because we have P here, both are 63. Then I'm going to go to T, and I'm going to go to U, and we're going to state by angle-angle similarity. Questions on that? All right, looking at this next one, again, we're going to determine if these two are similar. Well, this one's giving me three sides. This is only giving me two, but we do have the same angle right here and right here. We don't have another angle, and we have nothing over here to really prove that there's another angle that equals 37, so I'm going to have to go to sides now. So looking at this, I'm going to have US should be proportional in this case to XY, just based off of their locations. Now, I need to find the proportion of that. So we're going to take, let's do a small one over the big one. So this will be US over XY, which leaves us with 4 over 20, which ends up being 1/5 when we reduce. Now, this is where your calculators will come in handy. Let's say you have a fraction that you're not 100% sure what's going to reduce to. Take out those calculators. And I'm going to show you, why is it not doing, why is it not letting me do it? I don't know why it's not letting me bring up the TI. The best way to do it is this. I'm going to have to write it down for you guys. I'm sorry. My calculator's not working. You're going to type in parentheses 4 divided by 20. Close your parentheses. Hit your math button. And then go to 1, which is frac. And then hit enter. Then hit enter twice, okay? And then it should give you the 1/5. Does it? I hope. Okay. So if you're a little fuzzy on fractions, that's the best way to reduce. Okay? Is anybody still writing this down? Because I am going to have to erase that part. Okay. All right, now for the next one, we're going to see if these are, again, equivalent fractions or they're proportional. So we're going to look at ST and we're going to look at WV. So I'm going to take, now whatever I start with here, I did the little triangle over the big triangle. I got to continue that process. So I'm going to have ST over VW. This leaves me with 7 over 35. What does that reduce to? What does that reduce to? Bueller? Anybody? Good. It does reduce to 1/5. So these are the same. Since these are the same and we have congruent angles, we know that triangle STU is similar to triangle VWX by side angle side similarity. All right, questions on those two? All right, let's take a look at the third one again. We're going to determine, are these similar? Well, in this case, if we look, we have 3 sides for each and we only have 1 angle. We have nothing here that proves any of these angles. So we're going to have to stick with sides. Okay. So that means, let's just start, I'm just going to start color coding some things. So the first thing is I see that the longest side is right here and right here. So these are 2 that we know should be similar to each other. So I'm going to take, again, I'll just go little over big. So I'm going to have here SR over UV, which is 19 over 38. What does that reduce to? Anybody? Okay. 1 over 2, so it's 1/2. So now in order for this to be similar, all the sides have to have that same ratio. All right. So I'm going to look at the second longest side now, TS, and the second longest side here looks like it's VW. So I'm going to take TS over VW, which is 14 over 28. That one's actually kind of nice. That ends up being 1/2. Now, it's real tempting to stop here, but don't. Okay? Do all 3 sides. So here's 10. Here's 20. So this is going to be TR over WU, which is 10 over 20, which is actually 1/2 also. So without a doubt, these are similar. So we're going to have triangle RST is similar to triangle STU by side, side, side similarity. How we doing? Pretty good? All right, we're going to determine EFG and HIJ. So if we look at this, we see that we each have the 44-degree angle, which is pretty nice. So EG should be similar to JH, just based off the size, because this one's bigger than this one. So I'm going to take a peek at that. I'm going to have EG over JH, which is going to be 6 over 32. And that reduces to 3 over 16. Okay, so in order for this to work, the other one's got to be 3 over 16. So now I'm going to look at EF and HI. So EF over HI is going to be 5 over 25, which ends up being 1/5. These are not equal. They have to be equal. So therefore, the triangles are not similar. And that's why with side, 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 you need to check all 3 sides, because if one of them doesn't work, they're not similar. Okay? Any questions on this? Anybody still writing? All right, let's take a look at number 1. I'm going to clear the screen. All right, so determine if these triangles are similar, and if so, state how you know. All right, so we're given that IJ, this guy right here, is parallel to LM. All right, so first thing that sticks out at me is that I know without a doubt that this angle is congruent to that angle. How do I know that? How do I know that those two are congruent? What was the theorem? Go ahead. Yeah, vertical angles theorem. So I know those two are congruent. And now if I look a little closer at these 2 lines, here's these 2 lines. And I just need to pick a transversal. I'm going to pick this one right here. That's telling me that this is congruent with this. How? What theorem is that? Go ahead. Yeah, alternate interior angles theorem. So we know because of those, we know that we have the triangles are similar by, this is angle, angle similarity. Now looking at this, we're going to again have to identify those sides. So the easiest thing to do is identify the longest side first, okay? And put those over each other and see what we reduce to. So this first one's going to be 30 over 70, which reduces to 3 over 7. The next one, 15 goes with 35. Those are the smallest. So I'm going to have 15 over 35. That also reduces to 3 over 7, so we're looking good. And then I have 21 over 49. What does that one reduce to? Three over 7. So these are similar by side, side, side similarity. I want you guys to try these first 2 on the back on your own. Sure. Just sign it in out. Show of hands who's still working on these two. All right. So big reveal. Let's make sure we're doing this correctly. So the first one is they're not similar because they don't have the same proportion or same ratio, okay? The second one, if you subtracted these from 180, you would get 80 here. And if you subtracted these from 180, you would get 40. So these are similar by angle. Okay? Questions on those two? All right, let's take a look at the next one. So it says, now that you've determined similar triangles, let's practice solving for missing values if we know we have similar triangles. So in this case, we're not determining if they're similar, they're telling us that they're similar, all right? And that means we're going to have to find a missing side. So in this case, if we look, we see that these are similar by angle because they're showing us through these tick marks that the angles are congruent, okay? Now, as you can see, I have to make sure everything's lined up accordingly. So I'm looking at AB. It looks like AB and ED should be the similar sides. So I'm going to set this up as a proportion with the smaller triangle over the larger triangle. So I'm doing like little to big. Could someone let him in, please? Thank you. Now for this guy, BC, I see that it's EF. That should be similar. So I'm going to set this up as 6/12. So you guys remember this from like Algebra 1 or like middle school, right? This is a proportion. All right? So I'm going to multiply those two across and these two across, leaving me with 10 times 12 equals 6 times x. This leaves me with 120 equals 6x, and we're just solving for x. So divide both sides by 6. What is 120 divided by 6 going to give me? — 120 divided by 6. What's it going to be? 20. So now we know that ED is equal to 20. Okay? Questions on that? Okay, so this one, they are naming it. So they're saying TSR is similar to HGF. All right, so in this case, if I look, GF is going to be the same as SR. So I'm going to check. So I'm going to have 6/30, and I'm going to set that equal to, well, HG, which is our question mark, is going to be over ST, which is 45. All right, so I'm going to multiply these two across. So this leaves me with 6 times 45 equals 30 times the question mark. Six times 45 leaves me with 270. I'm going to divide both sides by 30. So I get that the question mark itself is equal to 9. So this is 9. we doing? Any questions so far? Anybody still writing before I move up? Okay. All right, so this one again, they're also telling us that this is okay. QRS is similar to KLM. All right, so here's KL. Here's QR. So this will be 3/6 equals. Now we're going to do the other two. ML, which is our question mark, over RS, which is 8. Multiply across, that's 3 times 8 equals 6 times your question mark. Or you can call it X or whatever you want. So 3 times 8 is 24. I'm going to divide both sides by 6. So I get question mark, in this case, ML, is equal to 4. How are we doing? Great? Grand? Is it easy? Yeah, that's good. All right, let's take a look at this next one. Again, I'm glad that they named this for us, so we got to be careful with what we're identifying as what. So if I look at PD, so I have D and P right here, that means that it's DF. So this is going to be question mark over 54. And because I started with this top triangle, I'm going to continue on with that top triangle. So it's going to be 12 over 54. Just looking at this, what do you guys think it's going to be? Without necessarily calculating, what's it going to be? Extra credit point to whoever can tell me. Go ahead. It's going to be 12. How do you know that? Yeah, 254s are both isosceles. After proportional, then they have to be. I'm going to add it to this one. Your name's on here, right? Yeah. Okay. Man, offer an extra credit point. Hands go up. All right, try the next two on your own. You try these two. right, show of hands. Who's still working on these two? All right. Oops. Let's check it out. So here's what you should have gotten for those two. Questions? How are we doing? Okay. That is it for today. Homework's on Delta Math. Now, some of you started it, but for some reason had the wrong number of problems on there, so I had to add a few more. So if you started it, I know none of you finished it, but check it out. All right. That's it. Those who are watching at home, have a great day.